All right, let's talk about one of the most fundamental questions in building pretty much anything online. What do you do when you get successful? So successful that your system just can't keep up. We're talking about scaling and the two major paths you can take to handle that growth.
So picture this. You launch your app and it goes viral. Overnight. Millions of users are banging on the door trying to get in. Now this is the dream, right? But it's also a complete nightmare for your one single lonely server, which is now just totally overwhelmed. This isn't just some made-up story, it's the reality that every single growing system has to face.
So you're at this critical fork in the road. The choice you make right now is going to define your system's growth, how resilient it is, and its ability to handle all that success. And you've basically got two primary options.
Okay, path number one. This is the most intuitive one, the one that probably pops into your head first. It's called vertical scaling, or sometimes scaling up. The logic is super simple. If your server isn't powerful enough, well, you just make it more powerful.
This means you're basically juicing up your current machine. You're adding more CPU cores for faster processing. You're jamming more RAM in there to handle all those users at once. And you're upgrading to faster storage so it can read and write data in a snap.
The best way to get your head around this is with an analogy. Let's say you start with a simple family car. When you need to carry more people, you don't go out and buy more cars. Nope. Instead, you trade in that little car for one massive, powerful bus. It's still just one vehicle, but its capacity is way, way bigger.
The principle is really straightforward. You start with a standard server, and you end up with a supersized, beefed-up version of it. It's bigger, it's stronger, it's more capable. But, and this is the most important part, it's still just one machine. So, this approach gives you a really clear trade-off. On the one hand, you've got simplicity. I mean, it's almost always easier to manage one powerful machine. But on the other hand, the cons, they are significant. That high-end hardware gets incredibly expensive really fast. And you eventually hit a hard physical limit. You can't just add RAM forever. But the real killer, the most critical drawback, is the single point of failure. If your one giant bus breaks down, well, everyone is stranded. Your entire application just goes offline. Poof.
That single point of failure leads us directly to our second path, which is designed to solve that exact problem. It's called horizontal scaling, or scaling out. Instead of making one thing bigger, you just add more things. So with this strategy, we're not upgrading our server, we're cloning it. We just keep adding more and more servers to a big resource pool, and then we figure out a way to spread all that incoming user traffic across all of them.
Let's go back to our analogy. Instead of buying that one giant bus, you buy a whole fleet of regular cars. Now, to make this work, you need a brand new, crucial component. You need a dispatcher who tells passengers which car to get into. This dispatcher is the absolute key to the whole operation.
In the tech world, that dispatcher is called a load balancer. It sits right at the front door, and all the user traffic hits it first. Its only job is to intelligently hand out those requests across that whole pool of identical servers. If one server is busy or maybe it even fails, the load balancer just shrugs and sends the traffic to the others. No big deal.
The advantages of this model are just massive. You get high availability and fault tolerance. If one car in your fleet breaks down, the dispatcher just sends people to the other cars. There is no single point of failure. And the scalability is, in theory, limitless. You just keep adding more affordable standard servers. The trade-off, of course, is complexity. Now you have a whole new set of problems to solve, like making sure every single server has a consistent view of the data. That's a huge engineering challenge.
So we have our two contenders, scaling up versus scaling out, the big bus versus the fleet of cars. Let's put them side by side and see how they stack up.
So the crucial point is this. Vertical scaling is all about power, but it has a hard limit and that terrifying single point of failure. Horizontal scaling, on the other hand, is all about distribution. It's theoretically limitless and way more resilient, but it definitely adds architectural complexity. One is simple but brittle, the other is complex but incredibly robust.
And this brings us to the final question. Which paths do the massive global applications we use every single day actually take? How do services that have to handle billions of users stay online?
Well, the answer is pretty clear. For any truly large-scale application, the limitations of vertical scaling, especially that single point of failure, they just represent an unacceptable risk. It's a non-starter.
So yeah, the internet is fundamentally built on this fleet of cars model. Now, in the real world, most large systems are actually a hybrid. They might use a few very powerful vertically scaled buses for really specialized tasks, like a core database. But the overall architecture, the
the thing that gives you resilience and massive scale is overwhelmingly horizontal.
And that leaves us with a final thought. The next time you open a global app on your phone, just think about the infrastructure humming away behind it. Are you a passenger on one impossibly large bus, just hoping it never breaks down? Or are you being seamlessly directed to just one car in a fleet of millions? Now you know the answer.